Welcome. Today's webinar is on asphalt forensics for essential employees. I'm glad you can join me. I'll talk specifically about forensics that I've been experienced and exposed to throughout my career, specific to asphalt pavements and runways. Remember, at the end of this webinar, you'll have the opportunity to request a quiz and take the quiz to get your certificate of completion. Regarding this picture, you could ask yourself, why is this truck blue? Or why is the shovel gray? Or why is the support bracket red? But in reality, you should be asking yourself something different. Forensic engineering, defined by Wikipedia, discusses the investigation of materials, products, or components that might fail, retrace our processes and our procedures to see what we can find out regarding fitness for use, and ultimately our root cause analysis should locate what went wrong, how to prevent it, how to design around it, and again, hopefully to know exactly what went wrong and how to avoid it in the future. And maybe that requires adding it into the specifications we're working to. The history of forensic engineering has matured and evolved over time, just like the projects that we build have evolved over time. So forensic engineering is ever evolving, and different forensic engineers you work with will have different approaches on how they move forward in resolving a problem or understanding why the problem occurred. I love this little book, Struck by Lightning. A big portion of what I enjoy out of it is understanding the difference between bias and random sampling and testing, about how figures don't lie, but liars sometimes can figure. So do take it into account when you're investigating and collecting data. Don't necessarily take samples only from the area that failed, but representative samples from around the entire project that you're working with to understand what went right and what went wrong, where it went wrong, how it went wrong, and again, how to prevent it in the future. It's going to involve on-site inspections. Most likely it'll involve some form of interview process with the people involved with the project. Maybe looking at diaries and test results that have been performed, potentially grabbing additional samples and having some experiments performed at an offsite laboratory. In investigations I'm involved with, I usually develop a matrix of testing protocol, test procedures, and test methods to follow, whether they're national standards or local standards or regional standards that you're working with, and ultimately to be able to obtain additional information from an unbiased laboratory, a laboratory that has had no role in the project. Typically an AASHTO accredited laboratory will be engaged when I'm doing forensic work, and other forensic engineers, I'm certain they do the same thing. Really no reason to include people who have been involved in the project at this point. The process we go through, typically, as I mentioned, I like to work with people to try to identify and quantify a problem and then solve. So like, I just call it my IQs, or actually you should call it your IQs, is can you identify as things are going on so that you can stop the project and quantify the problem and solve it quickly before it manifests into a very expensive problem. This is a good example of segregation after mixing. If you're only looking at one test result at a time and you don't pay attention to trends and tendencies, you might overlook something as simple as this, where as the mixture gets finer, asphalt content increases. It's a very good indication that the segregation of the hot mix is occurring after mixing, and you should take into account what's going on the slack conveyor, up in the silo, through trucking and installation, as well as the laboratory activities in splitting a sample for proper testing. This is a visual of segregation in a truck. You can see on the left side how coarse the material is in each drop, and on the right side how much more uniform it is. Now, I wouldn't grab samples from left and right and mix them together because you'll probably get the job mix formula, but you would sample and test the left side of each mini stockpile in the trailer and test them independently from each other. And what you'll find out in this case is the mix on the left is far coarser and much lower on asphalt content. That's just quantifying the problem. Solving it is, where did it come from? And it happens to be at the top of the silos where the gobhoppers, or batchers as you know them, weren't actually working properly. Many areas should be dealt with before going to build projects. Many times problems happen because of challenges from the cross-section that were detailed on the job. Not necessarily a construction issue or the mix selection specified in the contract drawings. It can be production challenges at an asphalt plant as well as construction problems. So we'll talk about each one of these as we go along. So again, cross sections. A lot of people are involved in this. Sometimes they are what you would call boilerplate type, where no matter what, in certain state agencies, they'll always mill a certain depth and put exactly the same thicknesses of products back into the roadway. Not job specific, but more of a umbrella approach, a corporate umbrella approach of one size fits all. This does lead to challenges. So again, I'd like to make sure you review your current policies that you have in place so that they're adequate for today's road maintenance and repair strategies. Several different cross sections led to several different problems. Here you can see none of them are good. They're all essentially very new pavements that have failed for one reason or another. I'll go through a few of these as we talk, but top left in general, the wrong mix and too thin of a surface course. The bottom one, improper installation of fly ash in the soil subgrade. Bottom right, lack of drainage, and then top right, variable thickness asphalt with inadequate compaction that occurred on a farm to market roadway, and only in one direction. This project here had cracks very early in its life. You would think, wow, something really went wrong during the installation process. But let me kind of unfold this for you and show you different phases. Here's the level course as it was being installed. You can see the white mark in about the favor in the right side of this pass. And that's where the asphalt actually was cracked. And you'd ask yourself, well, how did it crack? Well, when you specify a milling process that's only going to edge mill and you taper down to 0, you put a hinge point in the asphalt pavement that ultimately is going to cause a crack to occur right along that line as you densify it. Additionally, if you follow what I'll call an area of scabbing, you can see that the asphalt that's placed on the right side is going to be thicker than what's placed on the milled surface. So with the hinge point, you'll get a crack. With the other location, you'll get variable density. And ultimately, if you get variable density, you'll have variable smoothness as well. So it's not one of the better cross sections that you want to work with. This project here had a contractor building a new shoulder, and you could see all the moisture that was coming downhill for quite some time. So they never actually had the opportunity to build on a dry foundation. Some type of an interceptor pipe would have been better at the toe of that hill to collect the moisture, something like an 8 or maybe even a 10-inch diameter pipe, perforated pipe, and then to outlet the water into a ditch somewhere else. This right side of this roadway has been challenged for years because of the moisture that continues to get under the pavement. The right lane in this particular case has been milled and overlaid several times because of moisture from below. So really want to take care of that foundation in every case so that our pavement performs better. In this case here, the question would be, how come the pavement's only failing in one direction? Be a good question. What you don't know is this is a farm to market road. The grain silo is into the picture, so all of the heavily loaded tractors would go east in this particular case. What you also don't know is this is a brand new roadway that required a lower course and an upper course. The upper course was uniform, but in order to build the pavement with the proper cross section, the engineer specified a much thicker lift of asphalt at the middle of the roadway. And when that portion is an unconfined joint, the density that's achieved at that location is not going to be adequate to carry the load. Essentially, the primary failure mechanism on this project was the poor cross section. It wasn't poor mix or mix production. It wasn't the type of rollers they use. It just plain and simple was lack of density at the center line, with the pavement headed into the picture on the left side. So again, that unconfined joint was very low, and compaction actually caused the surface to fail within 2 weeks after it was open to traffic. Fabrics, grids, whatever product is used on road pavements, they need to be deep enough. They need to be installed properly. We don't want to put some type of grid system less than 2.5 inches deep. Many times I'm involved in projects that have very shallow depths, and at the high stress areas they begin to break and slip. Quite often the asphalt's blamed for this, but it's most often the fact that this is a bit of a bond breaker, and then when they're not installed properly, they'll cause challenges. So again, products can be used successfully, both geotextiles and grids, at the proper depth with the proper installation, and certainly under the proper traffic loading. Regarding mix selection and challenges, the longer I'm in the business, the more I realize we need to start to reduce the number of options available to industry because of transition mix. It's just too complicated to keep things all straight. Maybe we look at more of a low volume, medium volume, and high volume situation, and start to develop mixes that are appropriate for the surface as well as the binder or lower lift. So we start to reduce the number of mixtures that a contractor has to produce. Yeah, usually 30% wrap reclaimed asphalt pavement is a good number to use for recycling in asphalt pavements. And make sure that you use the correct liquid asphalt on the minus side to ensure that we don't have a brittle mix that'll crack. Add a little more oil into the mix by regressing air voids from 4% to either 3.5 or to 3. And then up your density by 1%, and you're going to have asphalt that lasts a good long time. These are some fairly basic items that as time goes by, I'm finding the trend is more and more common that increasing durability is a very important item that we need to continue to research, investigate, and promote. A different type of mix selections will cause different types of performance. The top left, I know, is an entrance to a commercial facility. The left lane failed prematurely, and it was the wrong mixture. It was dry and coarse. The rest of the parking lot is doing just great after 10 years. The road on the right is a low volume road mixture that was used on a high volume application, and that rutted considerably, about 2 inches within just a couple of months. Bottom left has a lot of recycle, dry mix, low density, and a very high percentage of dust, and it causes block cracking. And the bottom right picture is a perfect example of longitudinal joint density that's inadequate in one lane, but perfectly fine in the other. And you can see the rapid deterioration in the lane on the left side in that picture. It's a good example of using the wrong mix on an application. On the left side, those are dew spots. That means that the moisture is not going into the asphalt. On the right side, there are no dew spots. Yet it's a interstate type mix with polymer in it, very coarse. Well, it was very difficult, or obviously impossible, to get the adequate density to keep it impermeable. So moisture on this road is actually going into the asphalt. So the best asphalt for this application is on the left side. And then the resolution for this project was to seal coat it, put a waterproofing system on so that the water wouldn't actually penetrate into the asphalt. A lot of mix design challenges. People have different recommendations. Some think you can't get coarse enough. Some think you can't get fine enough. The reality is you want to be on a primary control sieve right along the maximum density, plus or minus 10%. You don't want to go on the outer ends of coarse and fine for mixtures. So in the case of a 9.5, or as you would call it, a 3/8 inch mixture, 47 is the middle of the spec range. It should be 37 to 57. And most asphalts are actually produced within there. I tighten it a little bit more. I like 40 to 55. I come to find out those perform pretty darn well. Again, others will have different opinions. I'm talking about dense graded. Stone matrix is different. We'll talk a little bit about that at the end of this presentation as well, how well they perform. This is a mix that's not even 6 months old. It's a local agency asphalt, very, very high recycle. Paving seams are pulling apart already, probably some thin asphalt installation. And on the right side, you can see that the joint's already failing on both sides. It's very strong, rigid pavement. We want flexible asphalt. We want asphalt that stays together. This was really a very tragic application of very, very high recycled asphalt in a local agency specification. So do be cautious and careful. It's okay to experiment, but I don't think we want to change our whole system just based on some preliminary research done in a laboratory. Again, just really pay attention to how things perform out in the field. So that last mix was incredibly stable, but wasn't flexible. And this is just an old picture I found from the University of Washington libraries that I kind of thought it was funny. Maybe this will be our next generation stability test in the U.S. Again, a little bit of humor there. For this poll question, the question is, how come that asphalt is so brittle, so cracked up? And it was very high in recycling, very low in density, and had extremely high number 200 or dust. Causes block cracking. And although the pavement's very strong, it's not durable, it's not flexible, and won't last the intended life. So again, be very careful in designing your mixes. And in general, the effective asphalt is something you want to probably increase with time. So there's no reason to do research and just publish, well, this is the best thing. It's always good to review your research, do some trial projects, and revise accordingly. Good research will be done when you accumulate information from people outside your very small circle that are working on the research, kind of vetting and whatnot. So don't just believe in shock and awe of research. If one document says it's good, doesn't necessarily make it so. Again, the mix design solution, I believe, for the future is going to be measuring more of the effective asphalt that's in a mixture, which is simple subtraction of the voids in the mineral aggregate minus the air voids of the produced product. So if they both go up 1% or down 1%, then you know your volume of bitumen effective, VBE, is unchanged. And so establishing and maintaining a minimum VBE is probably a good way to start looking at retooling your specifications. Some agencies have actually done it already. These are typical asphalt content values that I think you're going to find with many, many mixtures throughout the U.S. If you have good aggregate gravity test protocol, and the water absorption of the products, then the total asphalt will be as shown in this table. It works for many aggregates around the nation, even the world. I have come to find out some of the southern, in particular Mississippi, they might not absorb 2/3 asphalt in 1% of water absorption, but maybe closer to 0.5% or slightly less. So their absorptive characteristics of their aggregates is just a little bit lower than what most of us are used to. And that again is, if you have 1% water absorption, you'll get 2/3 of that in AC, or if you have 2% water absorption, you'll get 4/3 or 1 1/3 absorption of AC. And that way you can make some good predictions when you look at mixed designs. If you want a little more AC, just regress and target 3.5% air voids, or if you want even more effective asphalt, go ahead and regress to 3. And do make sure you select an appropriate crack test, such as a SCB or an iFit or Ideal CT. Those three seem to be catching on relatively well throughout the nation. So let's look at some production concerns, and then we'll wrap up the webinar with construction. So in production, you have to pay attention to the output from your input. Make sure the drum's warm enough. Make sure it's maintained properly. Heat and dry your aggregates adequately to make sure that you don't have dust balls. Watch out for debris, things like that. And we talked about segregation. If you see the back end of a drum, the flame is coming towards us. In this particular case, the ductwork takes out the elevated temperature, the steam, and emissions and whatnot. But if you have rust on one side, that normally means you have a valve that isn't adequate. So the right side of this drum is extremely elevated temperature, probably over 400 degrees Fahrenheit. And then the left side will be probably under 200 degrees Fahrenheit. That's going to be a challenge for producing the asphalt because it won't be uniformly heated and dried. There'll be some moisture captured, and obviously you're using way more fuel than you should, because a lot of it's just running right by the aggregates. So that's just a good telltale sign. You probably could measure the temperature across that drum with an infrared gun also. Dust balls shows up in the field, sometimes just a few areas, sometimes it's throughout the project. If you have a thin surface lift, almost inevitably all of them will fail within the first winter. Sometimes you can just core holes and replace with hot mix asphalt or hot poured rubberized joint sealant. But if you have a thicker lift, unfortunately you're going to be looking at potentially removal and replacement of the asphalt to make sure you get all of the dust balls out of the matrix. So we don't want to do that. This is a knife I held once where all I saw was a tiny little white dot at the surface of the asphalt. I just kind of rotated the knife around and it began to fall into a dust ball. And generally they're about the size of a golf ball. They start through mudding, which is always going to involve moisture in some part of the mix. It's typically going to be in the fine aggregates. The material accumulates on the far end of the drum as the gas stream is pushing them, kind of like plaster of Paris, just throws it up against the wall and it solidifies. Once it gets large enough, it breaks off in big pieces, calves off, so to speak, travels through the entire drum and ends up out on the roadway. It doesn't typically occur with binder or base mixes because the larger stones scrub the drum and keep it clean throughout production. However, it will occur when you're manufacturing leveling and smaller surface coarse mixes, upwards of a 1/2 inch nominal max size type mixture. There's one way to also eliminate the problem. Some contractors will put in what they call shaggy dogs. These are big chains on the outside, just kind of beat around and keep the recycling and the dust from accumulating in these areas. So again, manage the moisture, maybe increase stack temperature. Sometimes you can install a target on the inside of the drum to turbulate and make the gas stream go left and right. You could use a wrap system for the fine aggregate if you have a virgin mix, and that way you circumvent the far end of the drum. And then I'll show next picture, I'll have kiln chains and then watch your burner suction as well. So there's some kiln chains on the inside of a drum that just, again, flop around and knock on the dust so that it doesn't actually build up. So all of them, or a combination of some of these, typically takes care of the problem. If it doesn't, then unfortunately you have to move on to a different source. So you have to know which product from which source is causing the problem. And if you cannot eliminate the problem, you'll have to eliminate the product. I've also seen one contractor who has installed something they call a thumper on the outside of the drum, and as the drum rotates, it continues to vibrate and shake all of the material free. So everything's about thermodynamics for us for success in asphalt, and especially with regards to things like clinkers and unheated and dried recycled product that come out into the roadway. This is clean out of a drum after a few days of production. So some people have found out they have to clean out more often than they want, and that leads to, the vibrating the drum, adding chains, doing something that knocks it free so that you don't get that type of an accumulation, because you certainly shouldn't have to clean out a drum every few days. And again, if you don't clean it out, it'll eventually calve off and end up in the asphalt roadway. And again, we want it to be a uniform mixture that's placed out there. So for some construction techniques, we want to avoid segregation. We want to avoid low density on our joints. We want to ensure smooth ride. It takes the right ingredients, the right production, and the right placement techniques. The photo on the left is closing down a joint by flooding it with a product that fills the surface voids and penetrates into the mixture so that it helps the roadway last longer. It's a project of high segregation. If you get more than 4 or 5 pounds per cubic foot between any area on a pavement, you should be very worried and concerned about segregation. This one has over 10%, I apologize, 10 pounds per cubic foot between the two. And we used mineral filler on the unacceptable areas to close that surface up. So I do want you to be aware of, you can do forensics with nuclear density gauges real quick. It's just a reference between one side and the other and how well they're done. There's a construction project where a testing firm did density testing heading into course areas and out of course areas, and you can see the dip they found was 15 pounds per cubic foot. That's significant, and I believe the roadway's recommended fix was to do pavement patching at all the areas of heavy segregation. If not that, then maybe they did some type of seal coat or double chip seal and things like that with the contractor. Anyways, this is just a visual, or I should say a data collection process that is visually easy to see on the right-hand side of how bad the segregation was. Density problems on joints. Nice graph picture from, it's either NHI, the National Highway Institute, or Aztec Industries. Just shows how moisture has a pathway into our longitudinal joint, and then it begins to fail, and we have to remove and replace them. You can eliminate joints, or you can treat them in different ways. Here's a method of treating joints with a product after compacting. It's a penetrating prime of sorts, where they have already sprayed that one time and now they're spraying it a second time. But the left side of this roadway you can see is the unconfined joint, because the product is actually penetrating into all those voids. And on the right side, it's much higher density. When using equipment, steel, either heavy wheeled static roller, vibratories can work, just don't start them on the unconfined joint. start them on the confined joint, and then on confined joints, make sure that you use the rubber tire rollers. That's a nice drum with a articulated roller, or you can put the steel on the unconfined joint and then the rubber tire on the confined joint, left to right. This is a longitudinal joint seal. You can apply a very heavy mastic of asphalt underneath. It absorbs into, or it soaks into and absorbs into the asphalt by wicking up into it from the heat, closes it down. Really does a great job. Topical sprays work. After you densify the asphalt, you go ahead and spray on top of it like the picture I showed a couple slides back. And the FAA quite often will have you suck cut off 6 inches, and they just call it sacrificial asphalt because they know the density is so poor and they don't want it on the runway. Density really does help improve the long life of the roadways and runways and drag strips or whatever you have to do. The higher the density, the stronger the matrix. The higher the density on the joints, the less moisture can penetrate in and cause damage. Different ways of doing it: pave super wide, pave an echelon, which is side-by-side paving, and do look at increasing your density spec by 1%. Generally speaking, across the board, you can't go wrong. Work with industry to make sure that they're aware of it. And from a smoothness standpoint, whenever possible, use double skis. That'll give you the smoothest ride possible. These are just a few pictures that I like that I've taken over the years. This is a drag strip where they elected to use a material transfer device for smoothness and some remixing action of the asphalt as well. So continuing on with forensic, if you hit this sign, you will hit that bridge. That's meant to be a little bit humorous. But measuring asphalt successes, you really got to understand the risks involved if you do nothing. We do want to embrace new methods and technology, pave IR, intelligent compaction, just to name a few. GPS type paving, GPRs for density, just real-time information from quality control and quality assurance standpoints. And look at our options. If we do nothing, what is the cost to the road system? If we do something, what is the cost to the road system? So we have to balance our research and our implementation of new specifications. And we want to implement specifications that improve the road system at a reasonable cost to the agency. And then continue to develop future action items to look at. Some agencies specify echelon paving or wide paving at this point because they're sick and tired of the longitudinal joints not performing as well as they want them to. And that means working with the motoring public and letting them know that the road will be closed for a while. When you do research, make sure it's transparent. Do include people outside your very small group doing the research. Have it peer review and give open access to all the data that you're stating is having successes or failures, so everybody knows what's going on. Look at the data from your acceptance testing and make sure you do a rugged review of cause and effects. What caused something to perform better? Was it more asphalt? Was it higher density? Was it a plain and simple fact that you had a nice uniform gradation of the asphalt? So data in its totality, we really want to look at it because of cause and effect. And then we have to balance that with economics, engineering economics that goes into specification adjustments to improve the road system. That's just, I made that card for smart people. I don't get it, sometimes that's how I feel. I'm the guy on the right. And then I just kind of like that formula on the right as well with regards to Santa. I guess it's more appropriate if you're watching this at Christmas time. Again, open access has a positive effect on the scientific research. We want to make sure that the benefits we get from the research are shared appropriately and fully so that people can make their own proper decisions on what to do. If it's a small group of people looking at it, it's just really what they call circular research, where the outcome is known before the research is done. And you really want to avoid that. And certainly Be open and honest about all of the research that you're doing and why you're doing it. There's a funny, we analyzed 100 health studies funded by or supported by Mars, and 98% were positive studies. I do believe, though, Mars Candy does have a good outcome on you. The Illinois Center for Transportation and Industry is an example of working on research, and they do publish their findings. They're looking at ground penetrating radar to help see if it'll measure density on the asphalt pavements quicker, efficiently, and across the mat. If it does, we have more real-time data, and we don't have to wait for cores to know how good or how poor we're doing while installing the asphalt. So this is just a setup of the the equipment. Here it is at night being run. You see where they set it up over a location where they cut cores and use nuclear density gauge to see how it's performing. And that's just a night picture that I thought was kind of nice. So it can be done either day or night. So that's just research on ground penetrating radar. This is forensic work done after 20 some odd years of stone matrix asphalt being installed at the intersection of Williams and Margaret. It was a mixture that had no recycle. It was a 12.5 stone matrix asphalt, very high asphalt content, 2-inch surface course of slags, 2-inch binder course of dolomite, and they took samples and tested it, and the product is so good that it almost meets criteria for new asphalt in today's society. So it has really done extremely well. It's a couple magazine articles on it. One I was lucky enough to write with Wayne Jones of the Asphalt Institute, if you want to Google it. This is really impressive. This picture is an extraction of 1 foot by 1 foot area right over a crack or near some cracks, and you can see the bottom has a crack in it. That's existing asphalt that was there 20 years ago. The top 2 lifts are both 2-inch thick. The top 2 inches is steel slag stone matrix asphalt. The intermediate is the dolomitic stone matrix asphalt, and both doing extremely well. In this particular case, they use steel slag as a friction aggregate on surface courses. You kind of look at this and you wonder, did that crack try to come through? And I'd venture to guess it did, but the stone matrix has so much effective asphalt that it's self-healing and it goes back together with passes of vehicles in the summertime. So the torture of the winter never really took its toll on this project. In this picture on the right, a drone photo, you can see is no paving seam failures as well. It's a very good roadway. This is one of our gold standards of stone matrix asphalt performance in probably in the United States. So the holy trinity of success and durability from a good friend of mine, Abdul An from Chicago Testing Lab. He says, Tim, give me lift thickness, give me density, give me smoothness, and we're going to make a road last a good long time. Make sure that if you publish tables that specify minimum lift thicknesses, that you're at least 1/4 of an inch over those. Consider increasing your density by 1% by following the Federal Highway Administration's recommendation on high density. Look at your milling specifications. Get a better milled surface so that there's less scabbing and not as many deep gouges. Maybe you want to look at 3/8 inch mill heads instead of 5/8 or 5/8 instead of 3/4. Utilize double ski whenever possible and quit chasing yield. Make sure you chase smoothness. A lot of these are going to take working with the engineers you're working with. However, on your own, make sure that you take full advantage of the Asphalt Institute, the National Asphalt Pavement Association, and state asphalt pavement associations across the U.S. that offer webinars. And some magazines do the same. There's too many to name, and I don't want to leave anyone out, but you can Google some of these and you'll find a good training webinars on milling, paving, compaction, plant protocol, quality control, new techniques, using drones in construction, 3D construction, e-ticketing, The list is endless. We have so much to learn and so much to do to continue to improve our pavements and to train the frontline workforce so that they know what is new and what's current that works on building excellent pavements. Mark your calendar for our next Essential Employee Education webinar. It'll be in August. I apologize, I missed June. Been a little busy, like I know all of you have been. Stay safe. If you have questions, feel free to email me. And remember, the other item is to email me to receive your examination for this webinar. Send additional topics of some things you'd like to hear about. And again, I'll send you a certificate of achievement once you have submitted your examination back to me. So again, thank you for your time. Be safe. Have a productive 2020. And I will be back at you in August of this year. Have a good day. Bye.
Yeah, this is asphalt, and it's pretty good asphalt too. So make sure that when you're doing your forensics and reviewing asphalt, that it has the right ingredients, the right liquid asphalt, good production, good construction, good density and smoothness. This is a good road. Thanks for watching the webinar. And remember, don't forget to take your quiz.
To me like shoveling sand.